And so now let's have a look at the definition of negative catalysis or inhibitors. So basically, what does it mean by negative catalysis? Whereby the catalyst that reduce the reaction rate of one reaction, we call it as negative catalyst or inhibitor. So negative catalyst will slow down or stop all the reactions. So maybe in some of the reactions that we doesn't need the reactions to be happen, so especially in multiple reactions, so we may use negative catalyst to slow down or to stop that unwanted reactions. Okay, you need to differentiate or need to distinguish between inhibition and catalyst poisoning. So maybe inhibitor is used just to hinder the activity of catalyst, but the catalyst poisons, it may actually make the reaction to be stopped or to be irreversible. So you need to distinguish that. So there are two types of catalytic process. I have mentioned this earlier. Homogeneous catalysis. Homogeneous catalysis, whereby the catalyst and reactants are in the same phase. Heterogeneous catalysis, reactants and also the catalysts are in the different phases. So these two catalysis types are very important in industry. And the process of catalysis that involve biologically, we call that as enzyme catalysis. Okay, so you can read on your own the types of homogeneous, examples of homogeneous and also example of heterogeneous. You can find it in this slide or you can find it in other reading materials. Okay, this one also you can read it on your own. I just want to proceed with this slide, talking about the properties of the catalyst. Catalyst form, it can be in porous, it can be in molecular or monolithic, and the catalyst can be in supported form or maybe in unsupported form. So these types of catalyst form you can actually find also in other reading materials, but basically for porous catalyst, by definition it can be defined as the catalyst that has large area because of the pores, and the catalyst which is in molecular sieves, it has small pores which it can allow small molecule, and it prevent other large molecules to from entering. And the monolithic catalyst, it can be porous or non-porous. And then the supported one is actually a catalyst system which involve metal particles, and the unsupported one may involve promoters with that catalyst to increase the activity. So I'd like to introduce to you and maybe the structure of solid catalyst maybe. So for example, the catalyst which is in solid form, it usually has active phase, where the active phase will allow the reaction to occur. So basically the active phase consists of the composition may have metal or metal oxide. And the solid catalyst also may have promoter as well. And the solid catalyst also may need support. So basically the support is to increase the mechanical strength of that catalyst and also to make the catalyst to be thermally durable, meaning that when it undergoes an reaction with high temperature, the catalyst still can function well under a very high temperature, for example. So this is the function of the support. So just to give you the example of solid catalyst which has support, some of the support materials are the alumina, silica, zeolite, and other types of support, maybe carbon, titania, zirconia, magnesia, and also lanthanum. Okay, so what are the criteria of the catalyst? Usually we need catalyst in small quantity. And usually catalyst is very specific in certain types or certain classification of reactions. The catalyst may change physically, but it does not take part in the reaction. It just helps the reaction's rate to be increased or decreased. And the catalyst also does not change the equilibrium state of reaction. So what are the requirements? What are the criteria of good catalyst? So we call that as good catalyst if the activity of that catalyst is being able to promote the rate of desired reactions, and if the catalyst can be very selective to only the desired reactions, and it will slow down or retard the undesired reactions. Another criteria of good catalyst is it is stable, in which that the rate of reactions is stable at longer time. Another criteria whereby the catalyst can resist deactivation because of impurities or because of thermal, because of hydrolysis of other active components, and maybe because of other attrition due to mechanical movement. And a good catalyst also need to have a very large surface area in order active sites to allow reactions to happen. And this usually we can find in solid catalysts with porous structure.